Okay, what's up, everybody? This is going to be a short one. I've only got an hour. One of my students didn't show up, so I've got some time to work. This is an interesting problem. This comes from Reddit user KnitNewDust. It's probably some kind of video game reference. And they ask this pretty good question. This is interesting. I'm sure they're in class discussing right now. There's a theorem that says an inscribed angle that's the same arc of this this one that has two radii as its sides is half the angle of the other. So let's pull this up and see if I can draw it. I will keep the chat open behind this, so if somebody comes in here. Oh, actually, maybe let's make sure I'm actually streaming what I want. Okay, we're on the right thing. All right, so if somebody comes in and this is your problem, let us know. Say what's up in the chat. Okay, so we need to find the value of x. So we have two angles here, T and Q, and both of these are in terms of x, okay? And so since they subtend the same arc here, this arc from R to S, they both subtend the same arc, and RTS, right, this angle T here, is inscribed, and then this one's from the center to the same angle. I forget the name of that. This angle, Q, is twice T. So we can say that Q equals 2T. And so by substitution, 7x plus 39 degrees equals 2 times 5x. All right, so we can simplify here. We'll get 10x, so 7x plus 39 degrees equals 10x. And then I will subtract 7x from both sides. I get 39 degrees equals 10 minus 7 is 3x. And then we'll divide both sides by 3, and I get 13 degrees equals x, so x equals 13 degrees. And that's it. So you just needed to know that theorem, and this probably just came up, so that's probably why you don't remember it. But this angle will always have twice the measure. So angle Q will always have twice the measure of angle T, which is cool. That's really interesting. And it doesn't matter if like T was here and you drew it like this. Oops, sorry, this is kind of hard to do. Maybe I should use the ruler tool, but I don't want to take too much time. This will have the same angle. It doesn't matter where you drag T around the circumference of this circle, which is really neat. So let's see if I can find another one. Let's do a couple quick ones. I've been kind of lazy with this, doing the live streams and posting solutions, because I've actually been working a bit more online since this whole thing started, which is good. And I'm trying to keep up my own studies, which can be hard sometimes. My internet's being terrible. Hopefully the live stream's not too choppy. Oof, no, we're not doing any diffy Q. Let's see. Hopefully one of these comes up. Okay, never got this, but my sister who did it in AP Geometry in 10th grade, I can't do this and she might fail. Well, Madison's round garden. Last year, Madison won the city's most outstanding garden award for her square garden. This year, she plans to top that with her design for her beautiful round garden, and I think that's an excellent aesthetic choice. Madison's design starts with a sprinkler in the center and concentric rites of colorful flowers surrounding the central sprinkler. I don't know rights means here. Rings, maybe. Pavers will create both circular pathways and pathways that look like spokes on a wheel between the flowers. The sprinkler can be adjusted so it waters just the inner circle of the flowers, or it can be adjusted so it waters the entire round garden. Consequently, flowers that need to be watered more frequently will be placed near the center of the garden. Okay, and those that need to be need the least amount of water will be placed farthest from the center. That's very cool. The sectors of the garden will not be the same size, since they need to accommodate different types of plants. Here's Madison's design for a garden. The number of degrees in each sector has been marked. So, oh, this is wild. Okay, so here's the arc length of all the sectors. So question 1 is, Madison has only marked the degree measure on the arcs of the outermost ring of the garden. Determine the angle measure for the arcs on the inner and middle rings. So these are the same. You can see that this is the same angle. Do you notice any patterns? So this is the radius, inner circle of pavers. I don't know. Oh, so we're trying to find the arc lengths of all these. So let's fill this out. So we'll take this chart. Okay, so this is the instructive for the chart. And I'm just going to like, oh, maybe I should tell this person I'm working on their problem. Hey viewer, what's up? Hopefully you found your problem. Say what's up in the chat. What am I doing? Okay, I want to see we're about 7 minutes into it. So I already started, so we'll say 6.5 minutes. Okay, so, and I'll just repeat it here just in case this user pops in later and switched. So this first question, the degree, like, the degree is going to be the same for each thing here, okay? All of these are going to be 120 degrees, and that'll be the same for each angle. All of these will be 90. All of these will be 60. All of these will be 50, and all of these will be 40. Okay, so that doesn't depend on the radius, that's only the actual angle itself. And then, okay, so I screenshotted this thing, so let's go over and see if we can actually complete this. I want to pull this up just in case somebody comes in and there's a question. If you have questions, please post them in the chat or just say what's up. Math shouldn't be such a lonely business. Okay, so we have a formula that we can use to calculate arc length, and that is S equals R theta. Now in this formula, S is the arc length, R is the radius, and theta is the angle, okay? The important thing to know about the angle is that it must be in radians. So we have everything here in degrees. So I'm going to take a second before we even get to this. Let's put a pin in that for a moment, and let's convert all of these things. So we're in degrees. I'm going to multiply this by a conversion factor, which I will get from this equality. Pi radians is 180 degrees. So I want to cancel degrees. I'll divide both sides by degrees here. This equals 1. So pi over 180 equals 1. So we can always multiply by 1. That's the trick. Okay, this is where we get our conversion factors. And there we have it. So this is going to cancel the degrees, and we'll be left with radians. We can cancel it here and here. And then let's see, so this is going to be 4, so we'll go, this will be 2, this will be 9. So this is going to be 2 pi over 9, okay? So it's 2 pi over 9. Oh, actually, let me write it up above the angle. So 2 pi over 9. That's this angle here. 50 degrees, so same thing. So degrees cancels, cancel at 10. What else? We got any 5s? No, we don't got any 5s. Okay, so this is going to be 5 pi over 18. This is a 9 here. Then 60 degrees, that's going to be pi over 3. We know that one, it's on our unit circle. 90 degrees, that's pi over 4. It's also on a unit circle. This is 2 times pi over 3. 2 pi over 3. Okay, so now we've got our angles, which these are kind of hard to read, but I can't really erase them or it's going to erase everything. So we needed to get those in radians in order to use this formula. So theta is now in radians. We are all set to go. Okay, so each one of these cells in this chart wants to be an arc length. Okay, and I don't know what this question is like. What do you notice about the arc lengths? I think that's the next question. Well, they depend on the angle and the radius. Okay, they're directly proportional to the radius. That's the idea. So this is going to be, for all of these, it's going to be r times 2 pi over 9, okay, for this entire column. So that's going to be 20 pi over 9. And you know, they may want you to get an approximation for this, like actually punch it into your calculator and see what that comes out to. I'll leave that to you. It's not super hard. This one we're going to plug in 20 for r. So it'll be another 2 times this one. So this will be 40 pi over 9. Now this one will be 3 times here, okay? So it'll be 60 pi over 9, which we can reduce to 20 pi over 3. And that's just, everything just got plugged right into there. I'm taking my r's from here, I'm taking my thetas from across the top. Okay, so let's fill out this thing real quick. So now I'm going to take our theta to be equal to 5 pi over 8, do the second column, and I'm going to multiply by 10. So it's going to be 25 pi over 4. How did I get that? So that's going to be 10 times 5 pi over 8. We can cancel like this. 5 times 5 is 25. Okay. So then we got to do 20. Okay, so we can get a 4 out of here. We can get a 4 out of here. This is 25 pi over 2. And lastly, we've got 30 times 5 pi over 8. So we can cancel 2 out of here. So this is 4. This is 15. And so this is 50 plus 25 is 75 pi over 4. All right. Okay, so same thing. S equals r theta, and we're going to use pi over 3 for our theta. So pi over 3. First r is 10, so this is 10 pi over 3. And then the second pi is 20. 20 pi over 3. There's no factor of 3, so it's super easy. Then 30 pi over 3. We've got a factor 3 involved there, so this becomes 10 pi. Okay, same thing. We've got pi over 4 as our theta now. We're going to go 10 times pi over 4. We get a factor of 2 out of both of these, so this is 5 pi over 2. And then we're going to take 20 as our r. Can get a factor of 4 out of both of these. And then this one's going to be 30 times pi over 4. We can get a factor of 2 out of both of these, and we'll get 15 pi over 2. Okay, last theta, 2 pi over 3. Well, let's try a 10. No cancellation there. 2 times 10 is 20. 20 is our new radius. 20 times 2 pi over 3. No cancellations here. So that's 40 pi over 3. And then lastly, we'll take 30 as our r. This is 30 times 2 pi over 3. Here we have some cancellations, so this is everything's gonna have a factor of 3. This becomes 20 pi over, or no, just 20 pi, which we can see here is 3 times that. So that's a good check. Okay, so those are your values there. That question's pretty straightforward, just an annoying, like, repetitive application of that S equals r theta. All right, let's see what's the next thing here. Did we do this? Do you notice any patterns in the table? Oh, yeah, we could have. Okay, so this one actually has an additional row, which is not in the first one. Inner circle of pavers, middle circle of pavers, outer circle of pavers, and then they've pasted in this extended circle of pavers. So for 40 feet. So we're gonna do this row. I'm gonna write it here. So the last row is 40 feet. So that will be 80 pi over 9. And this is the same formula as before. This is gonna be 25 pi. This is going to be 40 pi over 3. This one's going to be 100 pi. And then here we will get 800 pi over 3. So yeah, that's that for question 2. What does it ask though? So, oh, area. Okay, I'm glad that I read this closely. These are now areas. So whatever I just wrote was wrong. So let's get rid of this. Paste this guy in here. Okay, so what do we want? The area of the sector. I don't know how to interpret this question. So they want the area of the circles, I imagine, or the sector. Inner circle of pavers, middle circle. See, these are saying circles. But I don't know if it wants, so obviously this one is the whole inner circle, like this entire slice of this pie. But I don't know if the middle circle wants just this area or if it wants to include this whole slice of the pie. From what it says middle circle of pavers. To me that reads like everything inside of this to include the one that we already calculated. But what would make sense would be to calculate just this band. Like that would be more useful information, I would think. Although you have to calculate one on the way to the other. So let me draw a picture of what I mean. So we have a circle, then we have a concentric circle, okay? And we want to figure out this area. That's obvious, right? That's the inner circle of pavers. But this middle circle of pavers area, I don't know if they just want this area or if they want us to include the previous area. We'll see. So what I'm going to do is I'm going to go inside out. And so the area is pi r squared. So the area of a circle is pi r squared. However, we want to take the fraction of that circle that is 40 degrees. So for instance, for the first one. So we'll multiply it by the fraction of the circle. This is 40 out of 360, okay? Which is what? 4 over 36, which is 2 over 18, so 1/9. And so we'll have to figure that out for each one. Okay, so all of these are going to be 1/9. All of these are going to be 5 over 36. All of these are going to be 60 over 36 is 1/6. And then this is going to be 1/4. This is going to be 1/3. And that'll be the fraction of the circle that's accounted for that. Okay, so what I'm going to do is I'm going to take the area of the outer circle, and then I'm going to subtract from it the one just inside of it. Okay, so I'm going to put the total circle areas here, and then we'll be able to subtract them. So let's do, so area equals pi r squared. Okay, that's going to be our thing. So we're going to use 40, and we are going to get 1600 pi. Then we'll use 30, and this will be 900 pi. Then we will use 20, this will be 400 pi, and 10, this will be 100 pi. Okay, so I used each of these radii in this formula here. And you know, I can show you how to do this, but essentially all I did was I squared 100, or squared 10, 100. Okay, that's where this came from. And the same for each one. So not super hard, you just need to know what you need to do. All right, so now I have all of the areas of the full circle, and I need to figure out what fraction is this. So let's start with the outside. So I need 1/9 of the outside circle, which has area 1600 pi. Okay, and this comes from, this 1/9 comes from 40 degrees divided by 360 degrees. This is the total angle of a circle, right? So this is the fraction of the circle that we're trying to take the area of. And I want to subtract from that 1/9 of the circle that's 30 feet. So if the outer circle is 40 feet radius, okay, and the one just inside it is 30, so here's the 30, I'm trying to figure out just this band, and I only want to take 40 degrees of that band, so 1/9 of that band. All right, and I'm not sure if that's exactly what they're asking for. They just may want 1/9 of 1600. Okay, so that that is all factors of 2 and 5 here. So this doesn't. So if that's the case, and you know, you can interpret it either way. I'm going to do the bands because those are slightly more interesting. This would be your answer. Okay, and that's the last I'm going to say anything about that. So from that, I want to subtract the area of the inner circle. So here I take 1/9 of this slice, okay, and then I subtract 1/9 of this slice from it. And you could write this as 1/9 times 1600 minus 1/9 of 900 if you want it. But having it factored like this helps you to subtract it easily. So this is going to be 700 pi. And are there any factors of 3 in here? No. You add up all the digits and it's not. So this is 700 pi over 9. Okay, so now let's do the next band. So the outer circle is 900 pi. We still want 1/9 of everything. So we'll take 900 pi minus the 1 inside that. All right, so okay, what are we doing here? All right, so let's do the subtraction. It'll be 500 pi. And does this reduce? So we've got 500, which has factor of 5, 2, and 5. Okay, so yeah, there's only factors of 2 and 5. This says 3, so this is 500 pi over 9. So that doesn't reduce. Oh, I'm sorry, I wrote this in the wrong spot. This should go here. And same thing. So this time we're going to take 400 minus 100. So 1/9 of 400 pi minus 100 pi. And that's just the band, right? So this is 400 minus 100 is 300 divided by 9. We'll get 100 pi over 3. And let me just do a step in between so everyone can see it. 400 minus 100 is 300. Got a factor of 3 here, a factor of 3 here. And then so we get 100 pi over 3. And let's do the next one. So this time there's no circle inside this, so we can just take 1/9 of 100. So 100 pi over 9. And so we have to do the same thing. Now we're going to use the fraction 5 over 36, which is 50 over, yeah, okay. And then we're going to do the same thing for all of these circles here. So we'll do 5 over 36 times 1600 minus 900. This is 700 times 5 is 3,500. Actually, we got some factors we can cancel. So this is 5 over, oh, and both of these have pi's in them. So this is 5 over 36 times 700 pi. And we've got 18,350. So this is 9. This is, let's see. It's going to be 1 and 7, so 17,175, which is 8, 2, so 13, so okay. So it's 5 times 175 over 9, which is 5, carry the 2, 35 plus 2, carry the 3, 875 over 9. Let me just double check to make sure this doesn't cancel. That's 15 plus 5 is 20. Okay. And there's a factor pi in there. And I'm going to try and do these quick, but just so I can see if there's, this might even be the last one I got before my session. Okay, so same process, right? We're going to do 5/36 times this circle of the area of this circle minus the area of the inner circle. Okay, so this is equal to 5 over 36 times 500 pi, and so we get 18,250. This will be 9. This will be 125. 3, 8, so that doesn't cancel, so this becomes 5, 2, 625 pi over 9. Then we've got oh, I wrote it in the wrong spot. Okay, so then we're going to do 400 minus 100. Which is 300. And so this has a factor of 3. That has a factor of 3. And then we can get 3 and 25. And so what is this? This is 125 over 3 pi, which is, yeah, and that does not simplify. And we've got, so there's no inner circle to subtract, so this is 536 times 100 pi. And this will get 9 and 25, so this is 125 over 9. Okay, and so now we got 1 over 6 times, and same thing. I'll just do all of the calculations. 1/6 times 700 pi, and then we got 3 and 350. So this is d pi over 3. Then we've got 1/6 times 900 pi minus 400 pi. And that'll be 500 pi over 6. So 7. Yeah, we're good here. Then this will be 400 pi minus 100 pi. And that'll be 400 minus 100 is 300. So we'll get 100 over 2, which is 50 pi. And then this one will be 1/6 times 100 pi, which is gonna be 50 over 3. Oh, you know what's interesting? This might be, so this is 3 times bigger. This is 5 times bigger. And this is 7 times bigger. Is that the same? So 3, 5, 7, which is going to give you 5, carry the 3. No, I don't think it holds up. So this is 3 times bigger, this is 5 times bigger, and this is 7. No. Well, it looks like it does hold up. So let's see if I calculated this one correctly. I might have made a mistake here. This one we got from 5 over 36 times 1600 pi minus 900 pi, which would be 5 over 36 times 700 pi. And this one is 49. And so we can go 1, 75 times 5 is 500 plus 300 plus 350 plus 25. Yeah, that's right. And then let's just check. Is 125 times 7 that? Equals 700 plus 140 plus 35 equals 875. Oh, yeah, that is the pattern. Okay, so that's easy. So what we'll do is we'll just find the inner circle first, then multiply it by these things. Okay, so this becomes 1/4, finding this one here, 1/4 times 100 pi, and that is 25 pi. So here's 25 pi. 3 times that is 75 pi. And then, what did I say? This was 5 times, so that is 125 pi. And then 7 times is 140 plus 35 is 175 pi. So let me check that one. 7 times 25 equals 140 plus 35. Yeah. And then let's find this one here. This one's going to be 1/3 times 100 pi, and these don't reduce, so this is 100 pi over 3. 3 times that is 100 pi. 5 times that is 500 pi over 3, and 7 times that is 700 pi over 3. And if you want approximations of these, put them in your calculator. You know, maybe that would have been faster. I don't know if it would have been faster. It'll probably take you that long to put them in. And let's just make sure I've answered everything. Oh, I should also check to see that no one is asking questions. Hey, what's up, viewers? Thanks for watching the thing. Do you notice anything interesting in the table? Yeah, I think that we noticed that this row is, you know, the inner area of the inner circle. The next one is 3 times the area of the inner circle. The next one is 5 times the area, and the last one is 7 times the inner circle. That's pretty dope. And it didn't depend on the angle. So, yeah, I don't know, you know, why that occurs exactly, but it is very cool. It's super cool. I like that a lot. It's nice to be able to notice those patterns. When you first start doing these things, it's so, you're just like looking at every detail of a calculation. Like multiplying, you need to know your multiplication pairs from the digits 0 through 9 and 10, 11, 12. You learn those as you get a little bit better with multiplication. And then eventually you memorize all the squares and square roots, and then suddenly it's very easy for you to add and multiply, and then you're really using those distributive and commutative properties and associative properties to your advantage with real numbers. Factoring becomes easy. You start to see when to cancel and when not to, you know, and suddenly you can start to notice these things. So just, yeah, do lots of math. Get in there. I think that you'll enjoy it more and more. And if you start to get bored or it's painful, just step away from it, you know. Let me actually, I want to double check and see what time my appointment is before I start another one. Where are we at? It's today. Schedule. Okay, I've got a few more minutes. I might be able to fit a short one. I don't know why, but this one just never showed up. Let's see what else we got here. Yeah, say what's up in the chat, people. If you have questions or if that helped, please subscribe. I don't know that this channel will ever go anywhere, but it's cool nonetheless. And I like to be able to help people. So the more people that are helped, the better it makes me feel. Let's see what this one's about. So I got deleted or something. Okay, so this is another, oh man, you're on a computer. Who is this? I'm going to shame you. Oh, no, I'm not saying that name out loud. That's not friendly. Not for the children. Okay, so this is hard to see, but they did give an explanation in the comments, or in the title here. So the full radius of this, okay. So this says The rear windshield wiper of a car rotates 120 degrees, as shown. Find the area cleared by the wiper. Round your answer to the nearest whole number. All right, let's do this. This is really related to what we just did, so it's a nice extension of that. And let me let this one know we're at minute 40. Okay. So yeah, I like this problem. It's a good problem. Let's add an image. And then I actually just want to quickly see what those measurements are. So 25 and 14, because they're kind of hard to see. All right, so 25 and 14. Oh, that's even harder to see. And that's in inches. So essentially what you have is you have a circle, okay, with a concentric circle around it. In the middle is the pivot point for your wiper arm here. Now your wiper arm rotates 120 degrees. And the end of the arm is 25 inches from the center. And then the end of the rubber bit, right, this inner rubber bit, so our rubber length is this length here, okay? The end of the rubber bit is 14 inches. So what we need to do is find what fraction of the, so find this fraction of a circle, which is 120 degrees over the total, which is 360 degrees, okay, total circle. And this is 1 over 3. So I need 1/3 of the circle, okay, the outer circle, which has radius 25, minus 1/3 of the inner circle, which is 14. So it's very similar to the last problem. If you didn't see the last problem, check it out. So here we have the area of a circle equals pi r squared, and so we want 1/3 of that because it's only going to stroke through 120 degrees. So it's going to be 1/3 of the circle. And we're going to take the outer area minus the inner area. So we're going to get 1/3 of the outer area minus the inner area. So this is going to be 25 inches squared times pi minus 14 inches squared times pi. And we'll divide that by 3. So 25 times 25, I don't know what this is. Let's figure it out. It's like 625 maybe. Let's see, so this is going to be equal to 400 plus 200 plus 25, yeah, 625. Okay, so we're going to get 1/3 times 625 pi inches squared. And units are important, write your units. It's good, like, practice for science. And let's do 14 squared. I'm actually not sure what this is either. So this is 10 plus 4 times 10 plus 4, which is 100 plus 80 plus 16. So 196, 196. Let me check that. Yeah. All right, good to go. Minus 196 inches squared. 196 times pi. Pi inches squared. Okay, 625 minus 196 is minus 200 minus 4, so it'll be 421. So this is 1/3 times 421 pi inches squared. And then this is 6, 7. Well, I guess it's not divisible by 3. Six plus 1 is 7, yeah. So this becomes, it's just straight up 421 over 3 pi inches squared. And they want you to actually approximate this. So let me type this one in. So this will be 421 pi divided by 3. and we're to round to the nearest whole number. So this is approximately equal to, let's give it a little approximate thing here, 441 inches squared. Yeah, that's your answer. And I think that's going to be the last one I do before my session. I'm just going to chill out for a few minutes. Rest of my voice, I talk a lot. Okay, if it helped you, please subscribe, like, comment. All of those things would help me out. Give me some motivation to keep coming back and helping people with their homework for free. And if you are loaded and rich, please give me some money to the Patreon. That would be really sweet of you. Otherwise, have a great day. Enjoy doing some math.